And action. Okay, so today we're doing multiplication of rational expressions. And so if you're like me and you think all the way back to junior high, I always found multiplication of fractions a lot easier than adding and subtracting them. Okay, so we'll do a quick review of multiplication of rational numbers, which is the multiplication of fractions. So step one, they say consider the factors of the numerator and the denominator. So our step one is factor. This is study sheet stuff. You can okay. Then they say if there are factors common to the numerator and the denominator, reduce by dividing out the common factors. So the next thing you do is you ask yourself, are there common factors? No. You got it. Okay? And then cross them out. Divide. Okay? Then the third step, they say multiply all the numerators together and all the denominators together. So our third step is going to be multiply and simplify. Okay? If you crossed out all of the common factors, you shouldn't have to simplify. That step will already have been done. But if you missed one, you'll be able to see it in your solution, and then you'll simplify there. So multiplying is kind of nice because even if you miss something, you can do it again at the end. So let's do some easy peasy examples. So if we look at our steps and we say, okay, we can't really factor just numbers, right? It's different if we have like binomials or trinomials. So our first step we don't really have to worry about. And we say, are there common factors? So in A here, we don't really have any. There's no common factor of 7 anywhere in the denominator or of 1 anywhere in the denominator. So we go straight to step 3 and we go 7 over 50. Okay? So if we do B now, same thing. We can't really factor these numbers, but let's see, are there any common factors? So one of the nice things about multiplying is instead of just looking for factors within one rational expression, like we have to do with adding and subtracting, you can look for factors anywhere on the top and anywhere on the bottom. Okay? So for example, in this one you can go, oh, well, 6 doesn't have a common factor with 10, or 9 doesn't have a common factor with 10, but it has one with 6. So you can divide both of these by 3. Okay, so you're allowed to reduce across the multiplication sign. Okay, so then for the 5, we know that 5 and 6 don't have a common factor, but 5 and 10 definitely do. So we know that this becomes 3 over 2 times 1 over 2. Okay? Yeah, exactly. So that's what I was saying before when I said multiply and simplify. You can technically go like, okay, 9 times 5 is 45 over 60, and then simplify there. But this is a really easy question, right? If this was a more complicated question, the more work you can cancel out at the beginning, the easier your life is. So we get the 3/4. Okay? So when you're looking for common factors, for example, if you're looking for common factors of the 9, you can look anywhere in the denominator. You can't look at anything else in the numerator though. Okay, so if you take something out of the top, you have to take it out of the bottom as well. You can't take 2 things out of the top. That's Justin. Yep, like so if we took something out of the 9 and 6 but not out of the 5 and 10, yep, Okay, so let's go down and we'll do both of these. So things are already starting to get more complicated, right? So these questions, I'm going to choose who does the next step. So we can't really factor these ones again, right? Because they're not binomials or trinomials. So step one is kind of already done for us. We don't have to worry about it. The next thing we have to look for is common factors. So how about Ashley? Can you tell us one of the common factors in A? Yep, so we can cross the two y's out. And oh, Jackson, can you tell us another one? Z? So if we cross the z out on the bottom, what do we get on the top? Exactly, so we just get to cross out the exponent. Okay. Kelsey? Exactly, so what would you reduce it by? Perfect. So we'll divide both of these by 4. Yeah. 12 over 4 is equal to 3 over 1. So I'm just showing like every step. So when we rewrite it, we'll go like 3x all over 1 times 3xz over 1. Like that. So that's the same as 3x multiplied by 3xz, right? It's dividing the 4. Yeah. No. Oh, no. Okay, we'll go like this. There. Is that better? Okay. Okay, so. Okay. So then we just get to multiply these. So we go, okay, well, our two 3's together gives us 9. And then we have two x's. We get x squared and 1z. Yeah. Okay, so when they ask us to state the restrictions, so our non-permissibles. And so if we remember, when we do our non-permissibles, we always look at our original equation, right? So can someone, maybe Justin, our non-permissibles, we look at our original equation and we find them in the denominator. So what do we have in our denominator? Yeah. So we know for a non-permissible that 4z cannot equal what? 0, exactly. And then what's the other one? Y, yeah. So y cannot equal 0. And then so we say, we don't really need that 4 there. We just say z and y cannot equal 0. Okay, so let's do B now. So same thing. We can't really factor this one, but those will be coming up, so don't worry. But we have lots of common factors. So Kevin, can you give me some common factors? Okay, so what should we have on the bottom here? Perfect. Okay, and Teresa, give me some other common factors. The C? Yep. So where should we be crossing the C's out? Wait, 3. Okay. Okay. like cross it out. Nope. We can. So, okay. So Sam, if I was to take out this other C, how many C's would I have on top now? Perfect. Okay. Okay, Josh? A squared. Awesome. Yep. Yep. So, a couple different options. Okay, and then there's still some other things we can cancel out. So, how about, I'm going to choose, I love it. Oh, Michaela. Okay, so Michaela, what kind of common factors do we see in the top and the bottom? Yep, 5. So we can divide by 5 here. And then we can divide our 40 by 5. So we get 1 here. And we'll get 8 here. Yep, we'll write it all out when we're done. Don't you worry. Okay, so Kelsey just asked, and I'm going to wait until everyone's listening. Pardon? Yeah. So another thing you could do, like I said, if you take something out of the top, you have to take it out of the bottom. So if you chose to, you could have kept this 5 here and divided by 5 here instead. So it's kind of like Josh was saying earlier about how you could take the B from 2 different places. But Michaela made a really nice choice because there's still a common factor between these two. So how about David? Perfect, 7. Yeah, so you could take like a 5 out of the 35 and the 40. Yeah. So there's no like, there's more than one route to the answer. Okay, so what do we still have? So, yes, Josh? If you took like the 5 out of the 35 and the 40, then you would have to do some simplifying at the end. More than one road to the answer with these problems. So, okay, so what do we have left? We have 1 c squared over 2d multiplied by 5b that's a 1. Look at how I make my 2's. Okay, this is a 1 here. This is a 2 here. Got it? Okay. Okay, and then so on the bottom we have 8a. So this is what we have left now, which is a lot easier to deal with than that. So 8. So as our final answer, we get 5 BC squared 16 AD. Okay, there. Mhm. Okay. Well, anything with fractions, I'll pause this for a second actually. Okay, so let's go down to example number 3. And so we're going to do both A and B. So this one's kind of nice, A, because we know, okay, our first step is factoring. Okay, so step 1 is already done for us. So our factoring's been done, which is awesome. One less thing we have to do. So we can go straight to canceling things out. So, should I choose? Aaron, what is one of the common factors that we can cancel out in example A? You got it. Okay. And Paul, that's another one. Awesome. Andrew, is there any other ones? No, exactly. So what do we have here? We have 1 over x minus 2. Awesome, thank you. Okay, so we go 2, and we go x minus 2, and just like that. You could, but even like, for example, in question number 1 on our quiz, unless you keep it in that factored form, you don't really see how you could simplify it. So I recommend keeping it in the factored form, because if you missed canceling something out, you'll see it if it's in the factored form. Okay? On a multiple choice, they might have the answer written as like x squared minus 2x over 2, but I'm okay with that. Okay? So we have to state the restrictions still, so we have 3 of them. And no, oh yeah, 4. Good catch. Okay, so Lucas, you want to give us one of them? The one I missed. Awesome. Okay. And Willem, do you want to give us one? Okay, so remember, when we're finding our restrictions, we know that it's our factors that cannot equal 0. Perfect. So if we go no, we have it because we have a factor of x right here. Okay? So we're still looking for 2 more. We have 0, we have -1, and Oscar, can you give us one? Awesome. X cannot equal +2. And our very last one, Kelsey. Perfect. Good work, team. You got it. Because our factors were, one of them is x plus 3. Okay, so for B, this one's not as nice because our factoring, this one's not quite as nice because our factoring's not done for us. So, Sam, what's that first question we always ask ourselves? I asked Sam. Did we see one of those anywhere? Sam, can you tell us where? Okay, so when we're looking for GCFs, we're just looking for within one portion. Okay, so maybe check this first fraction here. Okay, so which one? 2? In the top or the bottom? I'm asking what the GCF is. Okay? So, we're just looking for the GCF. Like we can even just look at this one here, 4x plus 16. Okay, so Sam, what's our GCF? Awesome. Okay, We also have a GCF in the bottom here. So, Lucas definitely is 7. Okay, so this is our first one. Our second one, we don't have any GCFs. But I am going to write this just in longhand like this. Okay, so Josh, what's something we can cancel out? What can we cancel out? Do you want to give them both to me? Okay. Okay. So the top isn't a difference of squares because this x isn't squared. If it was 4x minus 1, that would be a difference of squares. Okay, so from here, we say, okay, can we cancel anything else out? There's no other x's plus 4s. 4 over 7 can't be reduced, so we know it's